Okay, this section is section 6.2. It concerns the study of special right triangles. We're going to be drawing those special right triangles by rotating our terminal side to a particular location around the circle and using the rotation to find the angle at the center, which is going to define the type of triangle that we're in. The type of triangles that you're going to be concentrating on, and you'll see that the problems are going to lead you into a rotation that's going to result in either a 30-60-90 or a 45-45-90. Those are called special right triangles. They are studied pretty heavily in geometry, but if you have forgotten them, as I suspect you have, because you've taken that probably quite a number of years ago, 9th, 10th grade, I'm going to remind you of the formulas because you're going to be using them in almost every section for the rest of the class. So first, let's talk about a 30-60-90. Doesn't really matter which one we talk about first, but they do each have their own special formulas. Now, instead of deriving the formulas every time you go to do a problem that's going to require several steps in and of itself, so you might as well just memorize the numbers that result when you have a 30-60-90. I'm talking about the numbers that represent the legs and the number that represents the hypotenuse. The hypotenuse is going to be equal because you are studying unit circles. Unit circles means that the radius is 1. So here I've drawn a picture of just, a simple circle, and I'm going to put a triangle inside of it. And I'm going to remind you of the 30-60-90 formulas. Let's say from section 6.1 that one arm stays here while the other arm, here's your rotating arm right here called the terminal side. We learned terminology in that section as well as how to do a mixture of like conversion problems, application problems. But one of the things we learned is that this rotating side is called the terminal side. So let's say that rotates 30 degrees up in the air. That would mean this arc is 30. By the way, in these formulas, they call this arc length from here to here S. But it just so happens, and again, you probably don't remember this from geometry, that the arc length is equal to this angle right in here. So the arc length is equal to what's called the central angle. Both of these terms were discussed in section 6.1. Okay, that's called an arc length. This is called a central angle because it's an angle at the center of the circle. Okay, with respect to developing any kind of a triangle, you wait to see where your terminal side is going to stop. It will dig into the circle, and then you simply travel at a 90-degree angle to your nearest x-axis. That would be this one right here. So we're going to travel down until we get to the x-axis. This leg that runs up and down is going to represent in all the problems that we do, even though I'm pushing you a little bit ahead, but it does have to do with this section. This leg that runs up and down like a little y-axis, your vertical leg will always be your y-coordinate. Your y-coordinate is synonymous to your sine value. And let's go over this notation. Whenever you see a trig word, these are all what we call trig functions, and they each have their own formula that are related to the legs and the hypotenuse, the sides. They're all of these formulas are related to the sides of a triangle. So what you're seeing right here, SIN, that is an abbreviation for SINE, the sine function. What you'll see right next to it is whatever they've called the central angle, which in this case is S, but it can be called theta, beta. They could put a number there. If they put a number there, then that's telling you where, how many degrees to rotate this terminal side to. But here we're just giving formula, so I'm just going to go over the kind of angles that I want you to get really familiar with. 30-degree angles at the center, 60-degree angles at the center, and 45-degree angles at the center. So when you want to find out this y value, This is also known as the sine function. This leg, the horizontal leg, will represent your x-coordinate. The x-coordinate is synonymous to the cosine. That's called the cosine value. And again, this is just how far around the circle. So when somebody says, find the sine value at 30 degrees, that's because they're telling you the central angle is going to be 30 degrees. So if they tell you, find the sine value, it's really just the y value. These are equal. If someone says, find the cosine at 30 degrees, that means you'll be in a picture. This will be 30 degrees. And the cosine value will be whatever your x value is. We're going to talk about those in a minute. Then there are other formulas here, but first, before we go into the rest of these formulas, let's develop a 30, 60, 90. So right here, I'm going to put 30 degrees, and I don't know if I think I'm going to move that S because I'm squashing everything in. So try to take notes when you're taking notes in pencil. You'll be aggravated otherwise. Okay, so let's see if you remember this. Whenever there is a 30-degree angle here, this has to be a 60, and I can make this triangle bigger. First of all, you've been told that this right triangle is being drawn in a unit circle, therefore the radius is 1. The radius is the hypotenuse from the center all the way out to the edge. That is not a radius because it doesn't go all the way out to the edge. Okay, so this is 1. This is 30 degrees. And just so we have a bigger triangle, I'm going to move it over here. So we're not cramming it into that tiny right triangle. There's only so much I can do inside of a circle. So this is 30. We dropped down to the x-axis at a right angle. Therefore, this has to be 60. So another thing that you may have forgotten with regards to geometry is your triangle inequality theorem. I don't expect you to spout out these theorems or memorize them because you're not in a formal geometry class where you need the theorems to do proofs. That's not what we're going after here. This is more of algebra mixed with the mechanics of geometry. So in the triangle inequality theorem, it says that the smaller side, happens to be called a leg. These two pieces are called legs. This piece is called the hypotenuse, if you recall. But across from the smaller angle is the smaller side. Across from the bigger angle is the bigger side. And across from the absolute largest angle inside this triangle is the largest side. So in other words, this would be across from the 30, smallest side. Across from the 60, medium side. Across from the 90, the largest side. The hypotenuse is always the larger side. In this particular picture, that hypotenuse is also called the radius. And being that we're in a unit circle, that radius is 1, just to get you familiar with what you're working with here. Okay, now for a 30, 60, 90, there are two formulas. Here's one that goes like this, that the hypotenuse is 2 times the short leg. You have to double this short leg. This is called the short leg, also known as your y-coordinate, also known as your sine value. You have to start relating all these things. The reason it's the short leg is because it is across, this leg right here is across from the absolute smallest angle inside this triangle. Across from the 60-degree angle is what we call the long leg. Put an LL there for long leg and write it out somewhere if you want to. This long leg, also known as the X, also known as the cosine value. Okay, the reason this is the long leg is because it is of the two legs, you only have 2 legs. You have one that goes up and down, you have one that goes sideways. So of the 2 legs, it is the longer one because it is the one that's across from the 60 as opposed to being across from the 30. So you have the shorter leg and you have the longer leg. So the formulas go like this, that the hypotenuse is twice the short leg. So what number do you have to multiply by 2 to get a 1? The number 1/2. 2 times 1/2 is 1. So you could also think of it this way. You could think of the short leg if you want. If you want to look at the formula this way for short leg, it's the hypotenuse cut in half. Okay, these mean the same thing. You could either double the short leg to get the bigger number, the hypotenuse, or you could just take the hypotenuse and cut it in half. Okay, in any event, you should be able to double your short leg to get a 1. So that is the value for the y coordinate. Then there's one other formula for the 30, 60, 90. This is one of them, having the relationship between the hypotenuse and the short leg. And then there's the relationship between the long leg and the short leg. The long leg is simply square root of 3 times whatever your short leg is. Because all these formulas can be used in right triangles where the hypotenuse is not 1. That's when you have to know the generic formulas. They're just easier right now because of this 1 that we have on the radius. So in this particular case, the long leg is square root of 3 times the short leg. Our short leg turned out to be 1/2 because the short leg has to be half of whatever the hypotenuse is. So if you want to write the long leg like this, you could write it, here, I'll put it down here. Just square root of 3 times 1 over 2. So that's your long leg, always in a 30, 60, 90. Okay, now sometimes you're going to rotate, and instead of having the 30 at the center of the circle, you'll have the 60 there. And if the 60 is here, then the 30 is here. That just switches the short leg and the long leg, but it does not change these formulas. So you have 2 formulas that you need to know right now, and you will be filled with formulas. A lot of formulas in this course, as opposed to an algebra class. There's less in that kind of math class. So your hypotenuse is always twice as big as your short leg, only when you're in a 30, 60, 90, and your long leg is square root of 3 times your short leg. For this other triangle that I want to remind you about, the one that is 45, 45, 90, so this arm will be rotated 45 degrees up in the air. And in that case, when you come down to create your right triangle, if this is 45, this one up here has to be 45. Because these other 2 angles that are in the triangle with the right angle, they have to add up to 90. Because remember, all the angles have to add up to 180. So 90 plus 90, 180. In this case, this leg is equivalent to this leg, and that's because the angles are equal. If the angles are equal, the legs have to be equal. They're only not equal when the angles are not equal, like in this case, 30 and 60. Then you have a shorter side and a longer side. But these 2 sides are the same when you have a 45, 45, 90, and this is what they are. The hypotenuse is still 1. But the hypotenuse is also, if you want to relate it, see how it's related to a leg, square root of 2 times a leg. This is the only formula. There's only one formula for a 45, 45, 90. So let's go ahead and see what that leg is. Okay, I'm going to come right up here above the circle and get that leg for you. So in this formula, I'm going to put a 1 in for hypotenuse. That's this radius. So 1 is equal to square root of 2 times leg. So says the formula. And then I'm going to solve for leg. I'm going to get rid of this square root of 2 here, as well as here. And then you have that the leg is, because those cancel, 1 over square root of 2. Don't forget that when you're working with radicals, you don't want to really give a radical in the bottom. So rationalize it. Float that radical to the top. You're going to be doing a lot of that. Your algebra skills will be used quite heavily. So when you multiply the bottom and the top by square root of 2, you're going to get square root of 2 for your leg. I'll put it right here, over regular 2. And that's what each of these are for a 45, 45, 90. Okay, so this would be your x or your cosine. This is your y value, also known as the sine. Okay, in the next video, I'm going to be going over the diagram down at the bottom, and the rest of these formulas. I can only create 15-minute videos at a time with this camera.